Welcome to Innovation Ignition, brought to you by Ascendle, a series where we look at and discuss some of the hottest and emerging trends in tech. I think it's safe to say at this point in time, there is no bigger topic in the tech industry than AI. Joining me today, I have along Ascendle's senior software architect, Kevin Allen, to have a chat with us and actually host a bit of a demonstration on how to use a company's internal proprietary data with large language models. Kevin, thanks for joining us today.
Hey, Patrick, glad to be here. I'm actually really excited to be able to show off today's demo. I'm going to take you through a quick code review and show how easy it is to take some of the valuable data that exists in a company's private servers and use that as part of a simple AI application. So we're going to build something that answers questions like ChatGPT does, where you can ask questions right in your native tongue and get answers that sound like a person was speaking to you. But we're going to include data from an external data source that GPT has never seen before. And that will allow the user to ask questions that ChatGPT simply couldn't answer.
All right. Sounds interesting. And I know you're excited to jump right into the code, but before we get to that, let's talk business cases. Can you give me an example of what using private data in an AI chat model like this might look like?
Yeah, sure thing, Patrick. So let's say you own a company that sells replacement parts for tractors, and a customer of yours is trying to install a part you sold them, but they're running into trouble and they have a very specific question about the installation of the part. So they could go down the path of reading through the user manual, and when that didn't give them the answer they were looking for, they get their hands on the 800-page technical manual that a mechanic might use, and they read through all those pages in search of an answer. Or maybe instead, they could choose to go onto your company's Tractor Supply website and talk to a technical chatbot that has been created especially for answering these types of hard questions. And we're not talking about just a dumb chatbot that has been programmed with a bunch of frequently asked questions like we've seen several times in the past. We're talking about something that feels like you're talking to an actual mechanic who might work on tractors on a daily basis. And that customer could ask their specific question like, where is the fuse box located on a John Deere 4320 tractor? And while we've all played with ChatGPT and it's pretty amazing at answering questions, it's probably not going to be able to get them the answer they need because, like we were discussing, while the latest version of GPT is trained on a couple trillion parameters, it wasn't given access to your company's proprietary technical documents, whereas our tractor chatbot would be able to answer questions because it ingested all the company's technical documents.
Okay, so the chatbot we're about to build would be kind of like having a technical expert on the other end of the chat session, one who has memorized all the technical documents, maybe read through all of the past questions that people have asked that have been answered by real people. So if that data lives in the company's private data, which it often does in the form of knowledge bases, the chatbot in theory would be able to answer the question.
Right, totally. And it wouldn't be simply canned answers. The tractor chatbot would be using the large language model to give natural sounding answers, just like you get with ChatGPT.
Okay. I could see how companies could benefit from being able to do something like that. All right. What do you say? Your time to shine? Why don't you show us how it's done?
Great. So yesterday I put together a little snippet of code to show you just how easy this is to do. The code we're going to share will be a simple Q&A app where you ask a question and get the answer. So first thing I'd like you to notice is the files included in this application. This is a very simple app, and we have an API key file, which simply includes the key we're using to access the OpenAI API. And we have a PDF that we're going to be using for our reference material. And in the middle is the Python code that I'm going to share. Now, I know, Patrick, that you don't spend a lot of time in Python, but I promise you this is going to be painless. So let's very quickly look through the code. Oh, and by the way, if folks viewing this would like to deep dive into this code, we can do that. But for now, for the sake of brevity, we're just going to do a speedy overview. So up top here, we have our import statements. Where you can see up top here, you can see that we'll be using Streamlit to view our app in a browser window, and the LangChain large language model framework, which does some of the heavy lifting for our app, followed by your reference to the value in the API key file that I mentioned just a second ago. So then down here, line 12, we create an instance of the OpenAI large language model. We add some embeddings and then load and split up our PDF into manageable portions. Now, this PDF that we're using is one that many of our viewers will recognize as the best-selling book by our CEO, Dave Todaro, The Epic Guide to Agile. So if I scroll down to the bottom of this PDF here, you can see that we have 500 plus pages in this PDF. So let's move that back out of the way and return back to the code. After we've loaded and split the PDF, we load those pages into a vector database, which in this case is ChromaDB, and then we'll create a vector store and info object that LangChain can use. Down here at line 24, we'll see that we want to convert the doc and store it into a LangChain toolkit and add it to the toolkit as an end-to-end LangChain. So that agent is going to use our new vector store info, and the large language model will use the instance of OpenAI's large language model that we created earlier. So we're nearly done here. Are you still with me, Patrick?
Oh, I'm following.
Great. So the hard part is over, and now we're going to use Streamlit down here. See the ST? We're going to use Streamlit to show our application in the browser window. We have a title and a prompt where we can let the user ask a question, and then we just can display the answer on the screen. And that is it for the coding. We've created our entire application here in probably about 30 lines of code, and the only thing left is to run the app. So I'm going to go ahead and open up a terminal here. And while that is firing up, I'm going to give the screen back to you.
All right. What do you say we put this thing to the test? Start asking it some questions like ChatGPT.
Great. I love it. Let's go for it.
All right. So the app's ready. How about we pull up ChatGPT and we could do a little side-by-side comparison. We could ask it a softball question and a fastball, if you will, both from Dave's book, just to see what kind of different answers we're getting.
Love it. Let's go for it.
Pull up ChatGPT. And for the first question, let's do the softball. What is the recommended Scrum team size? Right. And we see in ChatGPT that we get the response of 3 to 9 members. And that follows a bit with what I know is in the Epic Guide to Agile, which is 7 plus or minus 2. It also follows the 2 pizza rule that 2 pizzas should be enough to comfortably feed your whole team. So Kevin, I'll pass it back off to you to show us what kind of answer we get in the application.
All right, Patrick. So we have the application running here, and I'm going to ask it that first question. So what is the recommended Scrum team size?
Yep.
Let's do that and hit enter. And here we go. So we can see the ideal size of the development team is 3 to 9 individuals. And my recommendation is a slightly narrower range of 7 plus or minus 2. How's that feel?
That sounds exactly right. You think it's ready for a more fastball of a question?
Sure. Let's bring it on.
All right. What is the spider story splitting method? SPIDR for spider.
Sure. I recall you talking about this in a recent talk on stage. Let's see. What is the spider story splitting method? Let me hit that and hit enter. And we can see it's pulling up the answer right now. And SPIDER is an acronym for Alternative Set of User Story Splitting Strategies. It stands for Spikes, Paths, Interfaces, Data, and Rules. And if we pull the little pull down here, we can see where it's actually looking up that information inside the book, chapter 22, page 291. How's that check out with you, Patrick?
It sounds right to me. Now let's pull up ChatGPT again to see what it responds with for that same question. What is this spider story splitting method? And as you can see here, ChatGPT doesn't even know what spider is. So this is an example of how you can actually use some proprietary information and train a model to sort of operate as that chatbot.
Right, that's true. Yeah. So were you actually using the data from Dave's book? It accesses that information and answers the question. It still has the full knowledge base of everything that ChatGPT has because it's based on GPT, the OpenAI GPT. We're calling the same backend that ChatGPT does, but we've given it this new PDF, so it has new information that ChatGPT doesn't have.
Okay, so now let's ask something that is very Ascendle specific. and I get asked this a bunch. What is the recommended way to write up a bug?
Okay, so let me share my screen again and let's see what we get. Okay, so your question is, what is the recommended way to write up a bug? So put that in and hit enter. Great, so that just took a couple seconds and it's pulling that data back right now. And let's see what it says. Recommended way to write up a bug is to use a standard format for the title and include steps to reproduce the result, expected result, and any notes. Format of this title is result, when, on, action, or location, if condition. And then there's chapter 27, page 381. Here's some quotes from Dave's book right there. What do you think?
That's awesome. So what if I had my data in something other than a pretty PDF like this? Are there other ways that we could load the data into the application?
Oh, sure. So let's say you had your data in a CSV spreadsheet. We could have just as easily given the code a path to the CSV instead of the PDF. The document loader that is part of this LangChain, the library that is used in this simple app, also supports loading HTML or Markdown or JSON, or you could even just point it to the path of a folder containing a bunch of text documents. Or with a few extra lines of code, you could even tell LangChain to point to a Dropbox path. It's all super easy to do, and the LangChain docs are actually quite excellent.
This is really great, Kevin. Thanks for showing this off.
Sure. The other thing I want to mention is this code, as easy it was to write, we could easily put that right up into a serverless function in Azure or as a Lambda function in AWS. So we're really kind of excited about this. We've got some other really cool ideas that we've been bouncing around in the Ascendle think tank, and I'm super excited to share those as well. So I hope we can do this again soon.
Yeah, I'm excited to hear all about them. Thanks for taking time out of your day to walk us through this, and be on the lookout for our next segment. Thanks, everybody.
Thank you.